7.5. Just shift things a little bit here, sorry. Okay, so 7.5. So we have, and we're given a bunch of different values here. So I'm just gonna kind of off to the side, write down all my variables, okay? So if 23,000 joules, so that's for Q, if 23,000 joules of energy is used to heat water by 4 degrees Celsius, what is the mass? Okay, so we are asked to take the value of C that we were given above. So C is just 4.18 joules per gram degrees Celsius. Okay, so my formula that I'm going to use, I want to still make use of, I'm just going to kind of do this on a little post-it so I can shift it as needed. Q is equal to MC delta T. Okay, so I want to shift this around to solve for M for this time. So M is equal to Q, and I need to divide by C and delta T. So Q divided by C and delta T. So now I can plug everything in. So Q, and again, I'm sorry, I write my Q's a little goofy. So Q is just 23,000 joules divided by my specific heat, which is 4.18, and my change in temperature, which is 4. And when I solve that out, I should be getting 1,375.6, or 60, sorry. Okay, so that's my answer for that one. For 7.6, the question is very similar. For 7.6, we are basically asked the exact same, we're given all the exact same information, only this time it's mercury and not water. So Q is still going to be 23,000 joules. M is still our unknown. C is going to be 0.14. So this number I got from my answer to 7.3. And then delta T is still 4 degrees Celsius. So I'm going to plug this in just like before. I'm just going to draw a little line here. So M is equal to Q divided by C delta T. So M is equal to 23,000 divided by, and this is the only difference again, the 0.14 times 4. And we end up getting 41,071.43 grams. Okay, so I want us to look at these two and then kind of think back to our answer to 7.4. So we have the exact same amount of water and the exact same amount of mercury. We have the exact same amount of energy going into both. The only difference is the specific heat. And we notice what that specific heat ends up doing to each of these substances. We are able to heat up a lot more of the mercury than we are to heat of the water. Okay, so it takes a lot less energy to heat up mercury than it takes to heat up water. If you're asking yourself the why of that, that's something that we're not going to talk about in this specific lesson. That's something that we'll get to in a bit. Okay, so I want you to kind of hold on to that question of why. You can kind of start looking back at the last couple lessons when we were talking about hydrogen bonds, but really that's a question that we just don't want to get into right now. Okay, and then finally, this last question. So 7.7, we have the specific heat of aluminum is 4,750 joules. So 4,750 joules. The heat energy is added to a 249 gram substance. So the mass is 249 grams of aluminum, and it has a temperature change of 21.1 degrees Celsius. It's asking us, oops, I wrote that wrong. This is not specific heat, this is Q. It's asking us what the specific heat is. Sorry about that. Okay, so here again, I'm just going to pull down this little post-it thing that I have here. So this is our equation that we're starting with. Okay, so if we want to solve for C, first I rearrange everything to solve for C. So C is equal to Q, and then I divide that by these other things that I needed to divide over to get Q on it, or to get C on its own. So Q divided by M delta T. So C is equal to, so Q is just 47,750 divided by 249 times 21.1. And when we solve all of that out, we end up getting 0.90 joules per gram degrees Celsius. Okay, so here I want us to just kind of take a sidebar here. This isn't specifically on this page, but I want to just kind of think about this for just a half a second, just to make sure that we get the gist of what this is trying to tell us. So C of H2O, so I'm just going to make a little table here. C of Hg and C of Al. So C of the specific heat of water is 4.18 joules per gram degrees Celsius. The specific heat of mercury is 0.14 joules per gram degrees Celsius. And the specific heat of aluminum we just calculated to be 0.90 joules per gram degrees Celsius. Okay, so if I'm going to rank these in order of easiest to heat up, so easy to heat or more difficult to heat, okay? The easiest one of these to heat is going to be the one with the lowest specific heat. So the easiest one to heat is going to be mercury. The most difficult to heat is going to be water. Whoops, as I'm miswriting this. Okay. Like staring at the mercury, trying to write water. Okay, so, and then aluminum would be in the middle. Okay. This is the type of thing that you should be able to get from these specific heats. Okay, this is kind of the take home that we want you to be understanding.